Hello and welcome to this video tutorial. We're going to be looking at vectors. Now in this Gizmo lab, okay, I'm making this video tutorial to help out in that this is an introductory lesson. Vectors are a new thing for many of you. However, dealing with vectors and how to deal with them mathematically is actually not a new thing for many of you. And you'll see that to be true as this goes out. In every vector, or in every Gizmo lab, excuse me, you're going to be introduced to various vocabulary terms along the way. So in this one, we're going to learn what a vector is, what the magnitude of a vector is, what the resultant vector is of adding two vectors, what a scalar is. We're going to learn about unit vector notation, what components of a vector are, and then finally, how to find what's called the dot product or scalar product. Okay, we'll get to that later in activity B. For starters, read the prior knowledge question with me. An airplane is traveling north at 300 kilometers per hour. Suddenly is hit by a strong crosswind blowing at 150 kilometers per hour from west to east. Draw an arrow on the diagram showing the direction you think the plane will most likely move, and then explain why. Explain your answer. Please pause the video at this time to complete your prior knowledge assessment. Remember, it's not about getting it correct at this point. It's about what you know or what you think you know going into the lesson. Pause the video and complete your prior knowledge section. Okay, I'm not going to go over the prior knowledge section because, again, it's going to vary for all of you depending on what your prior knowledge is coming into this particular lesson. Now, let's get into it. Displacement, which is a change in position. Velocity, that's how fast you're going. Momentum, that's the quantity of your motion. Acceleration, that's the change in velocity. And forces, right, push or pulls, are all examples of quantities that have both direction and magnitude. Direction being which way you point. Magnitude is the amount of something. So let's make a note of that. The word magnitude, right, means quantity or amount. Anything with direction and magnitude is represented as a vector. So I gave you 5 examples right here. So what are some examples of things that are not vectors? Well, things that are not vectors are called scalars. So an example of a scalar would be time. You can't point time in a particular direction. Mass, speed, distance, energy. Those are all examples of quantities that we deal with in our real world, but don't have a vector associated with them, don't have a direction associated with them. Therefore, they're called scalar quantities. Okay, we'll get into more of them later on. For now, let's get into how to use this Gizmo lab to get some understanding about vectors, their components, how to make sense of them, and then finally, how to add two vectors that are going in different directions. So it says, look at vector A and B on the vector Gizmo grid. The initial point of the vector is shown with a circle. You can see the circle here and the circle there. The terminal point, terminal means end, of each point is located at the tip of each arrow. So that's the terminal end of the vector. And so an arrow is a perfect way to describe a vector because an arrow is a geometric figure that shows directionality. It points in a certain way, and vectors have to have a direction. So each vector is described by two components, the I component and the J component. Okay, so for part 1, it says the two components written together make up the unit vector notation. What is the unit vector notation of vector A? That one right there. Well, let's go to our Gizmo. You should be logged into your Gizmo by now. Okay, if not, pause the video, log in. You can see vector A is this one right here on the left, and the components of it are in the upper left-hand corner. You can see where it says negative 2i plus 4j in the upper left-hand corner. So negative 2i plus 4j. We're going to make sense of what this I and j mean, because right now it doesn't make a whole lot of sense. So trust me, it'll make more sense as we go. Part 2. Move the initial point of vector A to 0, 0, the origin on the grid. So I'm going to slide this over right there. Okay. And notice the components for A did not change. It still says negative 2i plus 4j. So how did the components change? They did not change. The components stayed the same. Drag the terminal point of A so that it lines up with the x-axis. Which component describes the vector's position along the x-axis? So if I take the arrow, the terminal point, and I drag it along the x-axis, notice I have the terminal point at negative 5. Notice it says negative 5i plus 0j. If I drag it the other way to, let's say, 2, you can see that the vector components now say 2i plus 0j. In other words, which vector component describes the vector's position along the x-axis? It's the I component. The I vector component tells you the part of the vector that's pointing in the x direction. So let's make a note of that. I component goes along the x-axis, the x direction. Drag the terminal point of A so that it lines up with the y-axis. Which component describes the vector's position along the y-axis? So if I take the end of the arrow and I line it up like this, you can see if I put it at 3, you can see it says 0i because I'm not going anywhere in the x direction, but I'm going 3 units up in the y direction. So the y coordinate is going to be, the y component is going to be the j component. So the j component is going to be your y direction. Let's make a note of that. J component along the x-axis. I component along the x-axis, j component along the y-axis. Okay, let's scroll on and let's begin activity A. First, we need to change vector A so that it has this notation here, 0i plus 3j. Okay, now I already have it set up that way. Okay, you want to make sure that the arrow tip is pointing straight up at 3. And in the upper left-hand corner, you can see it says 0i plus 3j. It says, how can you determine a vector's magnitude and angle? Angle would be direction, which way it's pointing. Observe the magnitude of the vector. The magnitude of the vector is the distance. It's the length of the vector. So it's the distance from the vector's initial point to its terminal point. In other words, it's the length of the vector. The magnitude is written with what look to be double absolute value bars. The magnitude is a scalar or a number that does not indicate direction. Remember, magnitude means amount or quantity. What is the magnitude of vector A? Well, you can see vector A points 3 units upward. So vector A would be magnitude of 3. Now it says turn on show ruler and use the ruler to check your answer. Here's how you do that. Turn on show ruler. I'm going to drag one end of the ruler here, and I'm going to drag the other end of the ruler here. And you can see down below in the bottom middle, it says length equals 3. So that's how you can use and measure out the magnitude of the vector. It says turn off the ruler. Drag the tip of A so that its notation is 4i plus 3j. That means 4 units in the x direction, 3 units in the y direction. Like that. And you can see it says 4i plus 3j in the upper left-hand corner. Okay, what would be the magnitude of A now? Well, in this case, it's not in a straight line. It's in 2 dimensions. That means it has an x and y dimension. So what I'm thinking here is you're going to need to use Pythagorean theorem. 4 squared plus 3 squared equals c squared. So 4 squared plus 3 squared equals c squared. That would be 25 equals c squared. C would be the magnitude of A. And if I square root both sides, the magnitude of A would be 5. It's a 3, 4, 5 triangle. Now here's where you're going to explore. Part 2. A vector can be broken down into perpendicular vectors that describe its length along the x and y axes. These are called vector components. Turn on show vector components. How do the x and y vectors that appear for vector A relate to the I and j notation? Okay, show vector components, and you can see, I'm going to move this vector B out of the way. And you can see that the x direction, we're going 4 units in the x direction, and you can see we're going 3 units in the y direction, going up. And that's how we get 4i plus 3j. Those are the components. And again, 4 units in the x direction, 4i, 3 units in the y direction, plus 3j. Go ahead and complete number 2 on your own. Part 3. The xy components of a vector A form 2 sides of a right triangle. The length of the hypotenuse is such that the triangle will equal the length and thus the magnitude of vector A. So thing is, we used Pythagorean theorem to figure out that A equals 5. We really could have done this. Show ruler. Sorry, not cooperating at the moment. Let me see. Okay, so I'm going to move this here. I'll move this here. Turn on show ruler. Oops. There we go. Turn on show ruler. Oh, why this is not cooperating right now. Well, you should be able to drag, like I showed you earlier, you should be able to drag that piece right there and then the other piece on the other side. Right now it's not cooperating for me. Perhaps you'll have better luck doing that. I don't know why I can't do that. Okay, well, in any event, if you drag one end of that ruler to one side, the beginning side, and then one side to the tip of the arrow, you should be able to get that it's 5 units. Okay, but now if we calculate using Pythagorean theorem, well, we kind of did that up here already. So I'm just going to go ahead and copy that work. No reason to do it again. But we're getting the same thing. It says turn on show ruler and check your answer. Well, I tried that. I'm not having much success getting the ruler to move there. Hopefully you're having better success than I am. But in any event, you're supposed to drag the ruler onto A and measure the length of it. Hopefully you have better luck than I do. Okay, 4i plus 3j. Yeah, this is just not cooperating. Okay, like I said, I hope you have better luck with it than I do. I'm not getting much luck with this feature. I'm using an iPad too, so that also makes a difference. If you're using a computer, you might have better results than what I'm able to do. Okay, now I want you to try and find the magnitude of these. Okay, you're going to work part 4 on your own. So 3i minus 5j, that means 3 in the x direction. 3 in the x direction, negative 5 in the y direction. This means negative 1 in the x direction, negative 2 in the y direction. This means set your vector at negative 14 in the x direction and 3 in the y direction. Okay, you go ahead and pause the video, try part 4 yourself. Number 5. Besides a quantity's magnitude, vector also indicates direction. For example, on the Gizmo grid, suppose the y-axis represents displacement to the north or south, and the x-axis represents displacement to the east or west. Reposition vector A so that its notation reads 0i plus 3j. Just like that. What is the direction of the vector, north, south, east, or west? Well, it's pointing up, and up on a map would be north. Move vector A so that its notation is 2i plus 3j. I'm going to move vector B out of the way here. So 2i plus 3j. So that would be 2 in the x direction and up 3 in the y direction. 2i plus 3j, you can see in the upper left-hand corner. It says, remembering that x and y components of vector A form two sides of a right triangle. For a right triangle, the tangent of any triangle's ratio angles is equal to the ratio of opposite to adjacent side. In other words, the y side divided by the x side. From this equation, you can derive the following formula to get the angle. Angle is the arctan. So it's going to be the arctan of what? What's the y component? The y component is 3. The x component is 2. So we want to go ahead and put that into our calculator. Arctan of 3 divided by 2. And we should be getting an angle of about 56.3 degrees. This is the angle right here between the x-axis and the vector. Part 7. To check your calculations, select Show Angle Measure Tool. Place the protractor center circle on the initial point of vector A. Place one end of the protractor on the terminal point and the other end on the terminal point of A. What is the angle of vector A? Let's see here. So I want to show Measure Angle Tool. I'm going to drag the middle okay, 3, 2. I'm dragging the middle okay, this is not working very well for me. Okay, so what I'm supposed to do is I'm supposed to drag the middle part, the middle circle, right where the, and I'll draw it on this right here. Okay, so you've got your one circle, you got your middle circle, and you got this. So you're going to take, and again, I hope you have better success than I do. You're going to take the middle circle and you're going to drag it right here, okay? You're going to take the top circle and you're going to drag it right up here to the terminal end of vector A. Then you'll take this circle and you're going to drag it to the terminal end of vector X. And if you do that, you're going to get this angle, and it should be about 56 degrees if you're doing it right. Okay, go ahead and take some time to finish out part A. Pause the video and complete part A. This being 3 in the X direction, -5 in the Y direction, -1 in the X direction. So that's -1 in the X direction, -2 in the Y direction, -14 in the X direction, 3 in the Y direction. Pause the video and complete part 7. Okay, activity B, vector sums. Turn show X and Y components off. Okay, it says place the initial vector of A and B on 0, 0. Set the vectors so that A is 5i plus j. Okay, so we can see what A is. A is this here, 5 and then up 1. Like that. And then it says make vector B be over 1 up 3. In other words, -1i plus 3j. Like that. Question says, now, on the grid to the right, draw a vector that represents the result motion of the boat. So we basically have, it says, suppose a boat is crossing a river with a swift current. In the diagram, vector A represents the speed and direction of the boat. So this is the direction of the boat's headed. But then relative to the water, the water has a current that's going in this direction. And so vector C represents the overall direction of the boat. So vector C is what's called the resultant vector. So in other words, the motion of the boat is going to be off in this direction here. Okay, turn on show resultant so you can see it. Okay, show resultant, there it is, 4i plus 4j. Okay, and you can turn on show sum computation to see how it is that you come up with that. But you can see we're going 4 in the X direction, 4 in the Y direction. It says, what's the angle of vector C? Okay, I'm still not able to get this thing to work. Again, what you're going to have to do is you need to find the angle of vector C. So what you'll do is you're going to place, remember you have that tool, the angle tool. Looks like this. Place the middle circle right here in the origin. Place the top circle right here at the tip of A. Place the bottom circle right here on 4 on the x-axis. If you do that, you're going to get the angle of C. If you're doing that right, you should be getting 45 degrees. Okay. Select show ruler. and put the show ruler part, put one end right here, put the other end right here, and figure out what the magnitude of vector C is, the length of it. And we should be getting about 5.66, 5.7 if you want to round it up. Okay, part 3, turn off the ruler. Shift vector B so that its initial point is at the terminal point of A. Watch this. I'm going to take B and I'm going to shift it over like this so that it's the terminal point of B. What do you notice? Right? It says, what do you notice about the terminal point of B? Do you all notice that the terminal point of vector B points at the terminal vector C, the resultant vector? In other words, if I go what's called tip to tail, that means I'm going the tip of vector A right here goes to the tail of vector B right there. You can see that a straight line from start to finish would be the resultant vector C. Okay, you guys take a moment to write about part A. Pause the video. Okay, part B. Move B back to the origin and shift A so that its initial point is on the terminal point of B. Okay, so in other words, move B back to the origin. This time you're going to put A, you're going to move A. There we go. Move A so that A is at the terminal point of B. Notice you're getting the same thing. The sum of vector B and A is going to give you C. In other words, you're still going to end up at the end of C. Okay, take a moment to write about part 3B. Part 4, excuse me. Now look at the I and j components for vector C. How does the I component of the resultant vector C relate to the I components of vector A and B? Well, if you look, vector C has an I component of 4 and a j component of 4. How do you get that? Well, the I component of A is 5. The I component of B is -1. Add them up. 5 plus a -1 is 4. The j component of A is 1. The j component of B is 3. 1 plus 3 is also 4. So if I add the components, I'm going to get the component of the resultant vector. 5 plus a -1 is 4. 1 plus 3 is 4. Okay, take some time to write about part A. Part B, how is the j component of the resultant vector C related to the j components of vector A and B? Same logic, really. If I add the I components, I get the x component of the resultant, 4. If I add the j components, I'm going to get the y component of the resultant vector. Take a moment to summarize your part 4. Make a rule. How do you think the notation of C can be found using A and B? Well, C is the sum of the x components, that means the I, and the y components. That would be the j. Okay, so let's go ahead and take a look at the apply. Without using the gizmo, find the resultant vector of adding these two vectors. Okay, well, vector c would be what? Let's add them up. 2 plus 4 would be 6i, and then negative 3 plus 0 would be negative 3. So plus negative 3j. Now, the other way we probably should write this would be 6i minus 3j. Part B, turn on, show sum computation. Were you correct? If not, what was the actual resultant? So first, let's create those vectors. 2i minus 3j. So 2i minus 3j. Okay, that's the first part. And then 4i plus 0j. Okay, 2i minus 3j. Okay, I think that's it. 2i minus 3j. Yes, 2i minus 3j. Okay, and then the second vector is supposed to be 4i plus 0j. Okay, now it says to show some computation. We get 6i minus 3j. Right? That's what we got before. So we were correct. Okay. Please pause the video and try part 7 yourself. Okay. Part 8, move the vectors so that A is negative 2 in the x direction, negative 3 in the y direction, and vector B so that it's 2 in the x direction and 3 in the y direction. Why does the resultant vector C no longer have an arrow? When two vectors cancel each other out, they are said to be in a state of equilibrium. Identify another pair of vectors that would create a state of equilibrium. Please take a moment to respond to part 8 and 9. Okay, that concludes our video tutorial for the Vector Gizmo Lab. I hope you found it helpful to get yourself started. If you indeed have any other further questions, please make sure you let me know about those questions. Thank you.